Don't forget to like, share, comment, and subscribe. Want to learn more? Explore our engineering courses on our website. Link in the description. Hello and welcome everyone. Very happy that we are all together again. In this tutorial, we will explain some basics related to the world of electrical engineering that will be the guide for us in the rest of this course. So those are some very important fundamentals for anyone who works in the electrical engineering field. Are you ready? Fasten your belt and let's get started. The aim of this tutorial is to know what are the different ranges of the voltage that are used in the electrical field. Also, we will learn what is the relation between the different engineering parameters like the voltage, the power, the current, and so on. So let's go ahead. Indeed, there are some standard ranges of the voltages that are used in the different electrical applications, and those different ranges are categorized according to some standards for us to know what are the types or the categories of the voltages that we are working with. So the first category or range is the low voltage range, which starts from 1 volt and it ends at 1 kilovolt. So if you are handling any value of voltage that is in between of those margins, you are in the low voltage range at this condition. Now the second slice is the medium voltage category that has a range from 1 kilovolt to 66 kilovolts, or some other standards consider the medium voltage to end at 33 kilovolts. So anyway, those are the ranges of the medium voltage. Also, the third range is the high voltage range that starts at 66 kilovolt and ends at 220 kilovolts or 500 kilovolts. Also, this is according to some other standards. And for example, when you know that there is a step-up transformer that rises the voltage from 11 kilovolts to 220 kilovolts, so this means that the primary voltage of the transformer is a medium voltage and the secondary of this transformer is a high voltage. Or in other words, we say that it's a medium to high voltage transformer. Now the next range is the extra high voltage that ranges from 500 kilovolts to 750 kilovolts. And finally, we have the ultra high voltage that ranges from 750 kilovolts to 1200 kilovolts. So those are the voltage ranges map that can guide us for any value of the voltage to know what is the kind of this voltage that we are handling. Now, after knowing the borders of the voltage ranges, we need now to know some commonly used values of the voltage that are used much inside those ranges. So the popular values of the voltage in the low voltage zone as 120 and 220 volts and also 380 volts. So those are some standard values of the voltage that are used in our homes for the appliances to work on according to the American standards or according to the British standard. Also, the popular values of the medium voltage zone as 11 kilovolts, 22, 33, 66, 2.2 also, 3.3 and 6.6. So the medium voltage devices or transmission lines use those values very commonly, while the high voltage popular ranges are 66, 132, 220, 400 and 500 kilovolts. And for the extra and ultra voltage, the most popular ranges are 500 and 750, 1000 and 1200. But now you may ask, why we need to have some standard ranges of the voltage that the world works according to them? So this is because the electrical devices like the transformers, the generators, or the cables, for example, so they are designed mainly according to the voltage standards or those voltage standards. So we must have some standard level of the voltage that the world must work according to them to manufacture those devices according to those standards that the world works on. But if we specified many standards according to each country or each group of countries, at this condition we must manufacture some electrical devices with many different standards to cope with many voltage levels, and this will be an efficient solution. Alright, Now let's move to the main electrical system parameter. So the first parameter that we will work on of the electrical world is the active power, and its unit is watt. So it's equal to the voltage times the current times the power factor if we are talking about the AC power. So the power physical meaning is that it's the electrical energy that an electrical equipment can consume or produce at a specific time. Suppose we have a motor rated of 2000 watts. So this means that this electrical power that this motor must consume to produce a specific mechanical rotational power is 2000 watts. So it's supplied by an electrical power to convert it to the mechanical power corresponding to this electrical power. And also when I say that I have a power station with a power of 500 megawatt for example, so this means that this station has some generators that can generate an electric power of about 500 megawatt, and this power is transmitted to the consumer to get the benefit from it by converting it from its electrical form to some other forms that the user need, like the lighting purposes or to operate some mechanical loads or for the factory's loads and so on. Now, after knowing that the power equals to the voltage multiplied by the current, we need to know what is the relation between the voltage and the current. So we have two cases for the relation between the voltage and the current. Firstly, in case of constant power, so at this condition the current will be inversely proportional to the voltage, and this is logically true because of the voltage increases, but we need to get a constant power, so at this condition the current must decrease to have the same value of the constant power. And the case at which we have a constant value of power when we are talking about the power source itself, as the power source has usually a constant value of power. Suppose that we have the same power station that produces a constant power of 500 megawatts. Now if we are trying to transmit this power through a voltage range of 220 kilovolts, so it's a high voltage range, and at this condition the current transmitted will be 2.2 kiloampere, which is a small value. Now if we try to transmit this power on the high voltage range of 66 kilovolts, which is smaller than 220 kilovolts, so at this condition the current transmitted will increase to 7.5 kiloampere instead of 2.2 kiloampere. Also another example, if we have a constant power of 1000 watt and we need to transmit this power through a transformer, so if this transformer is a step up one and the voltage at the primary coil is 10 volts and we have 100 ampere. Now if we step up this voltage from 1 volt to 100 volt, so the transmitted ampere on the secondary will decrease to 10 ampere instead of 100 ampere on the primary side. So you notice that when the voltage increases, the current decreases as we have a constant power condition. Now the second case, if we are talking about an electric load that consumes the power, so we are not talking about the electric power source that supplies the power, but now we are talking about the load or the device that consumes the power. Now this condition, we will have a constant load with a constant power, so the resistive or the impedance is constant, and its relation is the voltage over the current. Now to get a constant resistance, when the voltage increases, the current must increase for the resistance to remain constant. So in that case of constant load, the voltage is directly proportional to the current. Now the electric current has some properties, and the most important of them is that it's affected by the cross-sectional area of the cable used. So if we are designing a cable to carry a specific value of electric current, so at this condition the cable cross-sectional area will be designed according to the current that will pass through this cable. So the electric current is directly proportional to the cross-sectional area. And this is because the cable conductor is supposed to be a tube which carries some free electrons of the electric current. So if we have a smaller cross-sectional area than what the electric current need to pass through it, so the path at this condition will be very narrow for the electrons to follow through the conductor, and it will have some collisions with the conductor atoms, which produces an increase in the conductor temperature. So there will be an excessive heat that produces produced in the conductor material, and there may be a failure in the cable, or it may be damaged or burned out due to the smaller cross-sectional area than it's required. On the other hand, in case of we have a larger cross-sectional area that is suitable for this amount of electric current to flow into it, so at this condition the flow of the electric current or the electrons will be very easy with no collisions with the conductor atoms. Now the final thing we have is the voltage designing conditions. So if the current was directly proportional to the cross-sectional area, here the voltage is directly proportional to the insulation level. This is because the voltage is nothing but an electromotive force, so the voltage can be represented by the force that those electrons are moving with. So we must ensure that the insulation is sufficient enough to be stronger than the voltage level to ensure that the voltage force will not break the insulation force like this case here. And for this reason we can note that at the high voltage cables they have a large insulation level than the low voltage insulation level, and this is because when the voltage increases the magnetic field produced from the cable will increase, so we must surround this large magnetic field and this large electromotive force with the sufficient insulation level to avoid the case of break of insulation. So I think that's enough for this tutorial about some electrical fundamentals, and at this point we have finished. Hope that's clear right now. Thank you for watching and see you next tutorials. Don't forget to like, share, comment and subscribe. Want to learn more? Explore our engineering courses on our website. Link in the description.